Let us continue with Mathematics Paper 1 of November 2021. And this is the final question, question 12. 12.1. A and B are independent events. It is further given that the probability of A and B is 0.3 and the probability of only B is 0.2. The first question is, are A and B mutually exclusive? Motivate your answer. So mutually exclusive events are when you have two events that have no intersection. So they do not touch or intersect in any point. But once you have two events that intersect, then they are not mutually exclusive. So that means that the probability for A and B is not equal to 0. And here we can see that the probability of A and B is equal to 0.3. So 12.1.1, it's not mutually exclusive because the probability of A and B is not equal to 0. The second question is, determine the probability of only A. So we need to consider the information carefully. We know that the probability of A and B is 0.3. So on a Venn diagram, if I have event A and event B, then I know that their intersection is 0.3. Next, the probability of B only is 0.2. So where B is alone, that is 0.2. That means that the full probability of B is equal to 0.5 because we need to consider the intersection of 0.3 and the 0.2. And to find A only, we know that these two are independent events. And the rule is that if A and B are independent, then that will be equal to the probability of A times the probability of B. And we know that the probability of A and B is 0.3. We don't know the probability of A, and the probability of B is 0.5 and not 0.2 because it said only B. So remember to include the intersection. And now if I divide both sides by 0.5, I see that the probability of A is 0.6. But the question was for the probability of only A. So the whole of A is 0.6 and the probability of only A is 0.3. Therefore, the probability of only A is equal to 0.3. The next question is, find the probability of not A or not B. So it really helps to draw out the Venn diagram. So not A means it cannot be as part of A, and not B means it cannot be part of B. So that means it must be outside of the events A or B. So in a Venn diagram, these values of 0.3, 0.3 and 0.2 need to add up to 1. So the probability of not A or not B would be 1 minus 0.3 plus 0.3 plus 0.2. And that is equal to 0.2. So the probability of not A and B is somewhere outside of those events, and that is 0.2. 12.2. A teacher has 5 different poetry books, 4 different dramas, and 3 different novels. She must arrange the 12 books from left to right on a shelf. Write down the probability that a novel will be the first book placed on the shelf. So the probability of a novel being placed first is 1 out of a possible 12 books. The next question reads, calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. So that means it's simply 12 factorial different ways. And you can do this calculation on your calculator and find that it's 479,001,600. And the last question is, calculate the probability that a poetry book is placed in the first position, the 3 novels are placed next to each other, and a drama is placed in the last position. So from the information given, we have 5 poetry books, 4 dramas, and 3 novels. So here I've drawn out the 12 possible positions of the 12 books. The question says a poetry book must be placed first. So for this first position, we possibly have one of 5 books. So we have 5 options for the first position. Then at the end it says a drama is placed in the last position. So in our last position, we have 1 out of a possible 4 books. So there are 4 options for the last position. Then it also reads that the 3 novels must be placed together. So imagine that I have the 3 novels all together. And these 3 books can be arranged in 3 factorial different ways. So we have 1 out of 5 books in the first place and 1 out of 4 books in the last place. And then the novels all together. And what we need to figure out now is how many different ways can we still arrange the books between the first and last book. So you count the novels as one arrangement because they need to move together. So that will be 1 position. And then there's 2, 3, 4, 5, 6, 7, 8 possible ways in which these 10 books can be arranged. So that is 8 factorial. Therefore, the total number of arrangements for this scenario would be 5 times 3 factorial times 8 factorial times 4 over the total number of arrangements, which is 12 factorial. And when I simplify that, I have 1 out of 99 chances. So this scenario would take place 1 out of every 99 arrangements.